Now, our objective for our whole lesson, it's behind over here. So I'm going to read it to you, and I just want you to think about it right now. So our job today and this whole week is to understand fractions as division in real world situations. Yes, sir. Can you grab one from over there? And that was what the 30-second sketch was for, to see if it worked. Okay, so markers down, whiteboards down. I want you to read this with me, starting at how many. Ready? How many different ways can you show, express 3/4? Show me thinking. Why did Miss Tinker put express in parentheses? Think about that. Why did Miss Tinker put express in parentheses? Turn and share. Why did Miss Tinker put express in parentheses? Turn and share. David. Sean, you're turning and talking. What are you doing? JJ, why did Miss Tinker put express in parentheses? This is a synonym for what? JJ's saying, a synonym for show. Okay, I would agree with you. I wanted to put this in parentheses so you guys could see another word for show. So, thinking. And this is our thinking time. Jaquil, warning. You are going to think of all the ways that you can express 3/4. And I'm going to ask again, whiteboards, markers, down on the floor right now. You're not using those yet. Thinking. Thinking looks like this, or like this. If you have an answer, show me like this. If you have more than one answer, show me here. Remember our respectful hands. Who has a different way to express 3/4? Brisa L. I'm sorry, I don't want to interrupt you. Did I draw it the way that you wanted me to draw it? Why is it drawn this way? Four is the denominator and there's 4 pieces for the whole. Okay, keep going.
And you should 3 out of 3.
Does it matter which 3? Who has another answer? Josiah.
Well, it's kind of like Brisa's strategy, but I did a rectangle and then divided it into 4.
Can you describe for me how I would divide that into 4 pieces?
Well, you can divide it in half.
Is this about half where you like?
Yeah.
Okay.
Then add a line in the middle of one of the top space.
So I'm going to do half of this half,
Then half of the other half.
half of the bottom half.
Yeah.
Oops. Okay.
Then you can flip 3 into the backwards.
Other answers. Carson.
I came up with an equivalent fraction to it.
Go for it.
15/20.
David.
I came up with that equivalent fraction. 6/8.
I'm going to give you time to turn and talk and now write other ways you can express 3/4. Go. Physically turn, guys. Physically turn and talk. Show on your board. Oh, that's another way. You're composing the two fractions, so you're adding 2/4 equals 1/4 equals 3/4. No, 3. Come on, write it.
How about do broken nose?
That's what I did.
3/4.
Like it?
Keep them on your board, don't erase. I would like to see them. Keep them on your board. Make as many as possible.
What else are you doing?
You know what I would do right now? I would make sure I had the same thing that my partner had, if I was still thinking about it.
Yes, you can.
Hold up your whiteboards. Hold them up. Hold them up. Rotate them so your classmates can see them. I've got about 3/4 of the class doing what I asked. Hold up your whiteboards. Rotate them so your classmates can see them. Okay, whiteboards down. Body is facing the front. Do not erase. Looking for students making good decisions. Anyone have something that they want to add to our poster that's not already on here? Oscar,
34 years.
one more time, please.
34 years.
Okay, now I'm going to go a little more in depth. How do you know 3/4 is equivalent to 30/40ths?
What I did was times the numerator and the denominator by 10.
Why do you have to multiply the numerator and the denominator by 10?
If you do it to the denominator, you have to do it to the numerator.
Okay. Something else that's not on here. Mia.
3/4 equals 9/12.
How'd you get 3/4 equals 9/12?
Okay, so I multiplied 3 times 3 and equals 9. And then 4 times 3 and equals 12.
Can I show you guys something? Hold on. I totally agree, Mia. Okay? Think about this fraction right here. 3/3. Because Mia multiplied 3/4 by 3/3. Think about that. What is another name for this fraction? Show me thinking. Think first. What is another name for this fraction? Josiah, I would appreciate if your eyeballs are here. What's another name for this fraction, guys?
A whole.
A whole. And I know in multiplication, if you multiply anything by 1, it's what? It's the same number. So I'm really just changing the how many pieces I have to get an equivalent fraction. Okay, let's get one more on there. One more on there. Seth.
30 40th equals 300
So our original fraction was 3/4. Can you say that one more time?
3/4 equals 3 40th, and 3/40th equals 340.
Oopsies, not there yet. So, Seth, what are you doing with your place value here?
And multiplying.
You're multiplying each one by what? 10. So we did 3 times 10 equals 30, 4 times 10 equals 40. Then we're multiplying by another 10. 30 times 10 equals 300. 40 times 10 equals 400.
Couldn't
You're
you just
extending the place value. Yes, ma'am.
You could just keep putting in 100.
Can't you just times it by 100?
You could. I'm going to show you one. I'm waiting for active listeners. Here's Miss Tinkers.
Where's Mr.
I don't know. We'll come back to it. Okay, show me the active listening. This is what active listening looks like. David, I'm waiting. Jaquila, I'm waiting. When I say go, you are going to have 3 minutes. How much time? 3 minutes. To get classroom ready, to get your square manipulatives from last week when we worked on the gallon conversion. Keep your whiteboard marker out, and then I'm looking for active listeners. Mind reader, do you have the timer?
Yeah.
How much time do you have?
3 minutes.
Go. A black marker from me. I do need it back. Thank you. All right, you're gonna write this on the bottom of your paper. Our objective.
Which side are you on?
Miss Brown's side. Thank you for asking. You're gonna write this on the bottom of the Miss Brown side, and we're gonna read it together. Thank you. Can you hold up your extras if you have extras at your table? Thank you. Hold up your extras if you have extras at your table. Flyers. If there's students at the candy table, they need papers too. All right, let's read this together. Starting at understand. Ready? Understand fractions as division in real world situations. Normally, we would have objective, and then it makes more sense because that's a sentence fragment there. So our objective is to understand fractions as divisions in real world situations. As division. I want you to take a second to annotate what you just wrote. Add any symbols, add any sketches, and annotate. For fractions, for example, what could you give for a fraction? What could you draw? What could you write? What does division look like? So for me, I might show a fraction as 3/4. I might show division as the division sign. Take about a minute to annotate our objective. Thank you, Oscar, for showing you're ready. Angel A for showing you're ready. Mia, you need to make a better decision, please. All right, thumbs down. Pointers to the word problem. Where should your pointers be? All right, we're starting at Miss Brown. Let's read it together. Ready?
Miss Brown decided to reward her small math group with ice cream. She purchased 3 cups of ice cream to share between 4 students. If Miss Brown were to share the ice cream equally, how much ice cream would each student get?
Pause. Show me thinking. First, we'll want to know, what is this problem about? If I were to ask you what's the beginning, middle, and end of a story, you guys can summarize it. Well, I want you to summarize this word problem. So right now you're thinking, what is this story about? Superheroes, identify yourself. Superheroes, tell your villain. What is this story about?
The story's about Miss Brown and her rewarding her small math.
What's Miss Brown doing?
Miss Brown is trying to figure out how much ice cream she needs for her small math group.
Can you remove your hand? Thank you so much.
She only got 3. Good. She has 4 students.
Got a couple tables showing active listening. If I give your team points, can you record it just on your table with an expo marker? Okay. If I give your team points, just write it on your table. All right. Angelica F. What is this problem about? Go ahead and share with the class.
This problem is about how much Miss Brown ice cream needs for the small group.
I want you to think about what Angelica said. I want you to put it into your own words in your head right now. So you're going to take what Angelica said, put it in your own words, and you might be the lucky student to restate it. Cindy. Go for it, Mia. Grab it. You'll have to go in my desk area. Cindy, you can share your answer right now.
It's about how I know. It's about Miss Brown and how she's gonna get ice cream for each student.
Every student in here?
Yeah.
Every student in here?
No, not every student. 4 students.
4 students. All right. So let's look at this graphic organizer. You have the before, you have the during, you have the after. Villains, read through the graphic organizer with your table partners. Go.
Change it. Explain. No.
Are you reading the sections of the graphic organizer to your superhero?
Correct. What strategies did my classmates use? Write them down.
Go through the graphic organizer. The before, the during, the after. Are you the villain?
Sense, justify yours.
Go ahead and read the sections of the graphic
I need
organizer
to
to your
change?
superhero.
Did your plan work? Check is my answer correct. What strategy did my class?
Team 5, give your team 2 points, please. They're showing active listening when they're done. Team 7, 2 points. Team 2, 2 points. Okay, this graphic organizer is separated into 3 sections. For this, you're going to talk about the before, the during, and the after in your small groups to solve this problem. The 4 says, what is the question asking? So what you're gonna do is you're gonna write in your own words incomplete sentences. Then you're gonna talk about your plan. I'm gonna give you about 3 minutes to do the before section right now. We're not solving the problem quite yet, but I want you to get the before section done. So you have 3 minutes as a group. Fill out those 2 pieces. Go. What's your job, guys?
I think
Fill out the floor. Who are you gonna do it with?
our table partner.
Your table partner works, or
Table.
your whole group? Okay.
Let's do it with the whole group.
Yeah, let's
Let me hear it.
Okay, so what is the question asking? Write in your own words in a complete sentence. Okay, so let's reread the question. How much?
Miss Brown decided to reward her small math group.
I thought we were going to read just the question.
3 cups of ice cream to share between 4.
What's your task, guys?
If Miss Brown were to share the ice cream equally, how much ice cream would each student get?
Okay. So are you guys right now restating and putting it in your words? Can you make a better decision, please? I'm sorry, but that's not a good decision. Okay. What is the question asking?
How much ice cream is Miss Brown? Yeah.
How much does she have?
She has 3 cups.
15 million.
I know how much.
Are you guys restating right now? Yeah. Okay. Max, share what your restating is going to sound like.
The question is asking us how Miss Brown is going to divide 3 cups of ice cream to 4 students.
Look at what your classmates are doing. Look at what you should be doing. Oh, thank you. It's okay, good.
Oh, it's Mr. Cooper's birthday.
Have you guys discussed the first part?
Yeah.
What is the question asking?
How much ice cream will 4 students get from 3 cups?
3 cups of what?
Ice cream.
Do you think it's important to mention the ice cream? Okay. So what else are you supposed to talk about with your group?
What's my plan? What is my plan?
What's my plan? And you guys can cross that out right now and say, what's our plan? Instead of my, what's our plan?
What's our plan? I'm just gonna shout mine.
Are you ready for the next step of the before? Or are we waiting for a classmate? So if you're waiting for a classmate, you can think, what is my plan? And then you'll share with each other. Josiah, are you ready to hear plans? Who has a plan? Are you ready to share? Yes. Okay, share with your group.
Okay, my plan is we have to divide 3 like 4 and try to make it into a fraction because she wants to make it into 4.
I have a question for you, Angel. How do you know it's going to be a fraction?
Because she wants it to be 4 and this will be, it will just be 1. And 1 student won't get ice cream, so you can't do it into a fraction.
You can divide
them into 4. Or 3 into 4.
All right, what's your plan, ladies?
So we want to divide 3, so we divide.
Okay, what's that going to look like? Oh, just describe it for me. You're not solving
It's gonna
it.
be like 3 can go into 4 by 1 time. So
Interesting. I don't know. 5,
so it's gonna be 1.
4, 3, 2. Thank you for getting quiet. Team 6, give your team 2 points. They're showing active listening. Okay. So we've all done the before part. You can put your thumbs down. We've all done the before part. Let's share. Lee. What is the question asking you guys?
How much amount of ice cream will both students get equally from 3 cups of ice cream?
Can you please repeat that?
Yes, please.
How much ice cream will 4 students get equally from 3 cups of ice cream?
Go ahead and restate that to your table partner, guys.
Three ice cream cups.
Missing cups, 3 cups.
Table 2 through 7, you guys can have 2 points. Showing active listening, what it's supposed to look like. All right. I did ask you to do the second part of what's my plan.
But didn't you say cross off mine to our?
I did tell one group to say, it's not my plan anymore, it's gonna be our plan. Show me on your fingers if you need more time. You can go 0 minutes to 5 minutes. Do you need more time to discuss what your plan will be? Okay, hands down. Hands out of our desks. Since you need more time, I'm actually going to have you guys go into the during part as well. So you're going to come up with a plan, and you're actually going to show it. I asked you to get out the square manipulatives. Hold up a square manipulative, please. Hold up a square manipulative. Good thing you have table mates that have some. Okay, last week we talked about conversions. What did 1 square represent? What did 1 square represent? A cup. Okay? So I gave this to you to see if you would like to use it. It's up to you to choose if you're going to use it. But I want you to think, what are some problem-solving strategies that I can use? So before I release you, let's brainstorm some problem-solving strategies. So right now it's your thinking time. Jaquil, we're thinking. What are some problem-solving strategies that I can use? Seth, we're thinking. Superheroes and villains. Take turns talking to each other. What are some ways you could solve a problem? Okay? Talk to your table partner. Not this problem, but what about drawing a picture? Can you solve problems by drawing a picture? What other ways can you solve a problem? Mentally? Okay.
We have so many layers of skin.
Sometimes. What are ways you can solve a problem? Not just this problem, but in general. You can use fractions. What about these guys? What do you call those?
Okay, so you could use manipulatives, you could use your
Counters, manipulatives. Table 4, give your team 2 points. Table 7, give your team 2 points.
Angel, all the way, not just like this.
Autumn, what did your group discuss? What are some general problem-solving strategies? Not for this particular problem, but how could you solve a problem in general?
Adding or subtracting.
Okay, so Autumn said adding or subtracting. I'm going to give that a technical term, and I could say using operations. Okay, let's hear from some of our other students. JJ, what are some other problem-solving strategies we could use?
Dividing.
Okay, so that'll go with our operations. Maybe you're going to divide
Multiplying.
or multiply. Again, using our operations. Angel Anguiano, what's a problem-solving strategy that you guys talked about?
Drawing.
Drawing what?
A picture or a model.
Okay, so we can draw a picture. The tapping needs to stop. Or a model. Shaquille, what's a problem-solving strategy your group talked about? What did we call these?
Manipulatives.
Manipulative.
You did better than me.
Yes, you did do better than David.
Manipulative.
Okay, let's read these 3 different things that we could use. So let's start with adding or subtracting. Ready? Adding or subtracting or dividing or multiplying, which is draw a picture and manipulative. Say it. Say it the right way. Manipulatives. Okay.
Manipulatives.
Thank you. All right. You have the plan.
5.
Oh, I can wait. You have the plan. You have the during. Right now, you have 10 minutes to work as a group. Go.
Nip.
Or dividing, multiplying.
Would you use every single operation in one problem?
Draw a picture.
Draw a picture? Is that what you guys want to do right now?
I scratched myself. I like dividing.
I like dividing using a picture.
Yeah, using pictures to divide.
Okay. Shaquille, who's the sidekick?
Mia. Wait, it's not Mia's sidekick. It wasn't Mia. I just got it out.
Thank you. Cool. Back to our work. Okay. What do we want to do? What's our plan?
Using pictures to divide. That really hurt.
Well, talk to your group. Not talk to me. Talk to your group. What are we going to do?
Yeah, use a picture to divide with a model.
Okay, what's the next step then?
Carry out the picture.
You have to do it. So let me see you do it. What is your model going to look like? It would be a good idea, but I would also like you to see.
paper, because usually this is way too little.
Could you use that?
Yeah.
Could you write on your desk with an Excel marker?
You can do that.
Yeah, you can totally do that. Now make sure you're looking at all parts of the graphic organizer. You just did the during, and you guys decided you're going to do what?
Divide.
Divide what by what?
3 4. 3 and 4.
Can you put that into a number sentence, an equation?
To divide 3 cups of ice cream to for 4 students.
Wait, there's 1 and there's the remaining.
Okay, so look at this next part. Does this make sense?
No.
Why not?
Because there's 4 students and there's 3 cups, so
And you're telling me how much each student would get when you're dividing like this? So each of the 4 students are going to get 1 cup of ice cream. Why not?
that's too much.
It's too much. So can you use another strategy? Look up at the board. Can you use anything you have in front of you to figure out how you're going to solve this? What are we coming up with? How are you going to divide what? By what? 3 by 4? Okay, so I see a model right here. Okay, you also have manipulatives you can use. So I see a little confusion. Everybody, get out your cups. Get your cups. How many cups do we have? Okay, Ms. Brown wants to give 3 cups of ice cream to what? 4 students. Maybe you're one of those 4 students. And so you really want to get an equal amount, okay? So what do we do with these 3 cups? Where's your 3 cups? You're going to divide the 3 cups into 4 pieces? Yes. Why?
because there's 4 students and there's 3 cups. And if you can, there's going to be 1 left over there. So the students not.
Okay, so what does that look like? And I'm okay with you drawing on your cups. I'm okay with you drawing on your table. So I need you to show me, what is that going to look like? Angel's got an idea. Are we still working on our plan part? Okay, so let's get focused on our during part. What's our plan? Now let's execute it, okay? What is your plan?
Our plan is going to be divided by 3 and 4. Our 3 and 4s, 3 and 4. And our estimated answer is 3/4.
How did you get from 3 divided by 4 to
4 divided by
3/4?
3.
Just a question.
Because have 2 ways to say this. There's another way to divide and multiply. When you multiply like 3 and 4, it's 12. Like that's 12 when you're doing this. And then when you divide it into 4 groups, there's 3. But since that's not a roll, because a roll is 4, there's 3 and 4.
Do you guys understand what Leah's saying? Okay. I need some help. Oscar, can you kind of restate for me what Leah's saying?
It's like 3 goes into a fraction, and then 4 goes into a fraction.
Okay. Here's the thing. I don't see any evidence of this anywhere on your papers. So how can you show me what Lee is saying? Maybe you guys need to look at our problem solving strategies and figure out how you can show me. Okay, I see the before part. Our plan is to what? You have something written down. What's our plan?
We're gonna divide 4 to 3.
4 what? What's the 4 represent?
3 to 4. 3 to 4.
What do they represent? 3 what? 4 what?
3 cups and then 4 kids. Like, hey, 3 divided by 4 is equivalent to 3.
This is like guacalas.
I'm concerned about your table. I need you guys to make better decisions. Do we understand? Okay.
I dropped this by accident.
Where does it go?
It's not my desk.
Does it matter? Where does it go? Thank you very much. All right. What's our plan?
We don't know. We're debating on it because we're debating to multiply or divide.
Okay, so who says they want to multiply?
Me.
Okay, what are you multiplying and why?
All right. I'm multiplying 3 times 4, and that equals 12 because we multiply.
But when we're problem solving, these represent things. What does the 3 represent? What does the 4 represent? And then what would your 12 represent?
The 3 cups of ice cream, and the 4 is all the students. And then that would get us 12
12 what?
cups of ice cream.
So reread the problem again. Let's reread it starting at Miss Brown. Ready? Miss Brown decided to reward her small math group with ice cream. She purchased 3 cups of ice cream to share between 4 students. If Miss Brown were to share the ice cream equally, how much ice cream would each student get?
So I think it's ounces.
How big is a cup?
16 ounces.
Do you have something that represents a cup here?
No, not yet.
Do you have something that represents a cup on your table?
Yes.
Show me a cup. Cool.
I'm all like, what bang?
Okay. And I might even have a cup that I can go show you too.
Not really. Right. One I like is that.
Chicken place.
No, because this is American. That's how you go. See, like when you do that,
cup pretty big.
When he does that, I'm like,
Wow.
Ooh,
It's a little.
this is a cup. This represents this. When we were doing our conversion last week, we were doing how many cups were in a pint, how many pints in a quart, how many quarts in a gallon. Right now, we're just dealing with cups.
It's a little.
Yes, sir. You now think we should multiply. What are we going to multiply?
3 and 4. Because if you say you still have the ice cream, then you split each cup of ice cream in half, and then 3. You can use one, since you pass out 3 halves.
Okay.
And then each other person. One.
Can you show me? Because I think something that would really help is if you guys could show it with a picture or show it with manipulatives. Take your cups. How many cups do we have? 6. Breathe your problem. How many cups do we have?
3.
Get out. 3 cups. Yes, ma'am. Okay. Show me 3 cups. Okay. Now you're talking about splitting the cups, right? Okay. So I want you to think, what is the correct operation for that? What would I actually be doing? And it's totally okay to draw on them too. That works for me. So what are we going to do? And I want you guys to think about that. Would you like me to leave this here?
Yes.
Okay. You solved it? Okay, explain it to me. Tell me what's going on.
Actually, I just came up with it.
So we split the cup in half. So
50.
Yeah, like we split the cup in 50, like in half. So we could like, so the 50, so the cup could like split in 50, and we could like give one half to this kid and one the other one, and then there's gonna be another cup to split in half, one cup to this one and one cup to the other one, and then there's gonna be one remainder.
So these two are one cup with the 50s, and then there's one cup left over, so we split that one in half. And then when we split, there's 2 25s and a 50, so
I see it. But I need you guys to be able to explain it. This is 1 cup. I need you guys to be able to explain it. It's up to you guys to determine if it's right. So what do you have right here?
A cup?
So a cup is 50 plus 50.
It's 100.
Can you tell me what 50 and 50 is?
It's got a whole.
But what does that represent? What does that number mean?
50 means half.
How does 50 mean half?
It's because
50 and 100. 50 is half.
Can I show you something? You're telling me this is half. Half of what?
half of a cup.
Okay, so 50 cup. That's half. This makes sense to you?
Yeah, because
Here, look. This makes sense to me. We can talk about 50%. We can talk about 50 hundredths.
Okay, that's all.
Or we can talk about 5 tenths. Or we can... So do you see what I'm saying?
Yeah.
When I don't understand what 50 is.
50%.
Can you put your strategy up on the board?
I did it. Well, it took forever. Oh my god, good luck. Take the board.
You don't have to keep telling people who's my ID.
I need my black marker.
Well, you didn't give me the chance to tell it, so.
That's in my car.
You're going in the house of doom.
Dun dun dun.
Shaquille, David, warning. Warning. Okay, I want you to write it big enough so that we can see it from across the room, okay? That noise needs to stop. Can I trade? Can I borrow that one? And then you take one from me over there. You solved it. You have like 2 more minutes. Did you ask your group mates? Who wants to go up and put their strategy on the board? You good?
Yeah.
Okay.
You're so
She
smart.
volunteered.
I was gonna do it.
Everything.
Okay. Who wants to show this strategy on the board? Cool. Okay. Go ahead and put strategy 3 next to Angie.
Yeah.
Make sure it's big enough that we can see it from back here, okay? What are we discovering from this?
Nothing.
Nothing.
It's because he's talking about Con Camp, which is a video game camp for nerds.
That's really sad. What I need you guys to do is make sure that you guys are focused. Seth, what would be the appropriate time to have that conversation?
Recess.
Seth, not Mia. Okay. Now look at what the cups are divided into. Do you see any like
Gotcha.
lines,
That
notches?
can help us
Okay.
because this could be a whole cup of ice cream, and then we can divide it.
Wait, there would be one half.
Okay.
One half to one student, the other half to the other.
How many pieces are you going to have if you split those between the 4 students? You have 4 pieces? But it needs to be shared equally. So you've got the other cup over there remaining.
This would be.
But Miss Brown isn't getting any ice cream. We can divide it.
Why would you do that?
Because there's 4 people on the top, and then half you can divide it.
And then be one and one.
So think about that, okay? Angie, now we can see it from across the room. Okay, you guys have about 2 more minutes, and we're going to listen to student solutions. 2 more minutes, and student solutions.
Is that supposed to be Jeffrey?
Can you label some things? Remember when we were talking about word problems and we have to show our labels? Okay, we've got labels here. We have a sentence. Do you guys have a solution? Did you solve it another way? That would be your next step. You solved it 2 ways? That would be your next step. So you multiplied 3 cups by 4 students and got 12 cups of ice cream. You multiplied cups by students and got more cups. Think about what you wrote here. Does this part make sense? 5, 4, 3, 2, 1. JJ again. As soon as I started counting, he's showing active listening, making excellent decisions. Everyone should be doing that. All right, let's start with strategy 3. You can do it. Our eyes are on the board. I need you to physically turn so you can be an active audience. If your chair is faced this way, turn in your chair this way. Your pencils are down. You are listening. You're being a respectful classmate. All right, Josiah. Remember to refer back to the problem. Remember to describe each step and what it represents. And then you are going to get comments and questions from your classmates. Okay, comments and questions from you guys. Where's a good place for those comments or questions to come from? Point. Point up there. Okay. And yes, it is a really good idea to have your problem with you. All right, Josiah, I've interrupted you enough. Go for it.
So what the 3 boxes represent is the 3 cups Ms. Brown has. So since if you did divide the 3 cups equally into each student, one person would not get ice cream. So then I divided all the cups into fourths. Then I drew 4 students, and then I divided each part of the cup equally into each student. And each student got 3/4 of ice cream because there was 4 students, and then each one got finished 3.
So, thinking time first. Look at what Josiah did. Look at our question stems. Do we have any questions or comments for Josiah? Thinking time first. Question time, comment time.
What are the X's in it?
The X's are to keep track of how many I used.
How do you know that's the correct answer?
I know it's the correct answer because each person got 3/4 of each one. So.
And I want to add on to that. How do you know it's reasonable? If we started with how many cups of ice cream?
It's because they're divided on each into a fraction. So if you're going to divide it into fractions, it's going to be which count you expect.
Last question or comment?
Can you show your answer in a different way?
That's actually going to be your guys' job. So, Josiah, you're not on the spot, but keep that in mind, guys. Can you show your answer a different way? All right, let's go with strategy 2. Strategy 2. Remember to refer back to the problem.
What I did was I divided 3 by 4, and I got 1 and remainder 1, and so I changed it 1/3. But I respectfully disagree with myself.
Can you explain why?
Because I realized when Josiah was doing his strategy that with only 3 cups, there's one student who wouldn't get an ice cream. So I decided that it should be 3/4.
So I want you to look at what Angie did, guys. And I want you to think about the reasoning that Angie just experienced. And I want you to explain to your table partner, we'll start with superheroes. What did Angie just realize? Superheroes, tell your villain. What did Angie just realize?
She just realized that she just realized that every student needs to like getting ice cream. So when she
thought each person would get ice cream, but she noticed that one person would be left out without getting any ice cream at all.
Give your team 2 points. Team 4, give your team 2 points. Okay, do we have any questions or comments for Angie? I have a comment. I think it is absolutely fantastic that you use reasoning to disagree with yourself. I think that's absolutely amazing. Okay. We have another question or comment. Nope. Okay, anybody else?
When you were doing this problem and you got 1 through 4 for each student, how did you know it was 1 through 4 to if you add 1 through 4 3 times, it wouldn't get you to exactly 3 cups?
That's why I changed my answer.
Last question or comment?
When you wrote the problem, what were you thinking was gonna happen? Like when you were doing it?
Can you elaborate?
Well, like, you know how, were you thinking like that each person was gonna get ice cream? It was like a normal division problem.
I thought it was a division problem because you were kind of dividing ice cream to kids, but I think that just kind of has a certain dividing that you have to do, and I didn't do the right one.
All right, and let's look at strategy 1. And we will do our applause at the end of everyone's strategies.
What I did was I split the 3 cups into half. So I had 2 50s and I had 4 50s altogether. So for one student, I put 50 for all of them, and then I had a cup left. So I split the 2 50s in half. So I got 25. So I gave each student 25.
Thinking time? Thinking? I think we need a little more clarification, so let's see what the students come up with. Questions, comments from you guys?
How do you know that's the right answer? I don't know what's the right answer.
You still don't know, and it's okay to not know, okay? It's important that we tried it. Any other questions, comments?
How did you get the denominator as 50?
There's no denominator.
Yes, there is. What denominator did we talk about? Can I help you out? Maybe this will help your classmates see too. Autumn is saying 50 out of 100 is what she was using. So, do you see what she has separated into each of the students? Looking at each of those student shares, how much out of 100 would each of those students get? Look at 50 and 25. Think. What's 50 and 25? What is it, guys? 50 plus 25. 2 quarters plus 1 quarter. 75. 75. So Autumn is saying each student is going to get 75 out of 100 cups. Something to ponder. Okay. Your job right now, take one of these strategies and put it for the after part. What strategies did my classmates use? You're gonna write that right now. And we do need to give a round of applause. We can give a loud applause. Nice job, guys. Okay. Pick a strategy. Write it down for after. Yes, sir.
Are we supposed to do it as a group or separate?
No, this is you. You have about 2 minutes to copy down your classmate's strategy. Okay? If you need to get a drink, you can get a drink. Are you guys done with this? Yeah. Okay. Okay, pencils down, eyeballs up here. Pencils down, eyeballs up here. Let's read our objective one more time, starting at objective. Objective. Pause. I'm waiting. Ready? Objective. Understand fractions as division. Now, in real world situations. Sorry, guys. Well, in my word problem, Miss Brown had how many cups of ice cream?
3 cups of ice cream.
And she wanted to share that evenly or equally between how many students?
4.
How many students, guys?
4.
Oh, wake up. So what we are doing is we are dividing 3 by 4. A lot of you guys started here. This one is 4 divided by 3, and what we saw with Angie's strategy is that this would get 1 1/3 cups. And if you add 1 1/3 4 times, that's going to give you more than the 3 cups. So what we're doing is we're really representing this as a fraction. And we got, that is what you said, David. We got 3/4 cups of ice cream. Questions? Flip it over. That's your exit ticket for today. By yourself. Exit ticket for math. That's your exit ticket. You best, and we will discuss it tomorrow. But that is your exit ticket.